Hello, everyone, and welcome back to another episode of CleanTechies, the podcast, as always, sponsored and made possible by Next Wave Partners. On today's episode, I interviewed Ryan Gavin of Schneider Electric, and we discussed microgrids on a very kind of broad standpoint: what they are, what they can accomplish, what are the benefits of them, what are some of the challenges of creating and building these microgrids. Just had a very interesting conversation at large, and I hope you enjoy today's episode. All right, welcome to the podcast, Ryan. How's it going today?
It's going well, Silas. Thank you. How are you?
I'm not too bad. It's a beautiful day in New York City. You're in Toronto? Is that correct?
I was living in Toronto the last couple of years, but with COVID and everything that came with it, I relocated to Halifax, Nova Scotia, to wait things out and see how the world changes over the next few months.
Yeah, it's a different place for sure. Well, very good. Well, I appreciate you coming onto the podcast. I guess, for everybody listening, could you just give us a bit of background, kind of what you're doing with Schneider, how you ended up here, just kind of whatever really comes to your mind to chat about.
Yeah, for sure. So I guess we'll take it back to my mechanical engineering degree, where I entered the workforce as a project engineer for a telecommunications company. And the experience, mechanical and electrical projects, integrating generators and switchgear and UPS systems, HVAC systems into buildings, got me exposed to the electrical world, where I came across Schneider Electric. Joined Schneider about 5 years ago on a whim, honestly. Once I got to know a bit more about Schneider and what a great company it was and the culture there, I've transitioned my kind of career to, what can I do for Schneider Electric? And I'm not sure if you saw in the news last month, but Schneider Electric was named the #1 most sustainable company in the world, according to Corporate Knights. So it's just another feather in the cap and another reason why I love working for Schneider. So
very good. And so what exactly are you doing now with Schneider?
I'm leading microgrid sales and business development for Schneider Electric Canada.
Got it. Okay, that makes sense. Yeah. So I guess, there's obviously, I've heard this term myself thrown around a lot, microgrids, and I think it would be really helpful if you could give kind of an overview as to what is really, when people talk about a microgrid, kind of what exactly does that mean? What applications can it be used for, and how can it really help reverse and reduce climate change?
So the term microgrid is definitely thrown around a lot, and it can mean a lot of different things in a lot of different settings. But at its core, a microgrid is a group of interconnected distributed energy resources that can act on their own or in parallel with the utility. So the idea is the distributed energy resources, which can be sources of generation, loads, or energy storage. If the site is not connected to the national grid, those distributed energy resources can stabilize themselves and operate as a single entity. In places where those microgrids are connected to the grid, they have a power management system that can reconnect to the grid as needed. So it provides resiliency. And from a sustainability perspective, like you mentioned, those distributed energy resources can be PV solar, wind turbines, or any number of renewable energy technologies. And of course, battery storage or other forms of energy storage systems.
Yeah. So on what scale, when they talk about microgrids, like what is it? Is it generally, is it like for a city block? Is it an entire city, a complex, a major company out that has a complex of their own, like Apple, for example? Like what is the scale that we're talking about?
A microgrid really ranges from a residential home to a commercial industrial building, to a large factory, to a university campus, to a community, to a small island, to a remote mining operation, for example. On a very small scale, at your house, let's say, you could have a a small rooftop solar system, a small battery in your garage, maybe a small natural gas generator, and your house is likely connected to the grid. So in the event that the grid is lost, your battery or generator becomes the anchor resource for your microgrid, and along with the solar, it's able to operate and provide that resiliency whenever you lose your utility. And when the utility is present, your solar and energy storage are providing sustainability and energy savings to your home. If we think of that application to a larger building, in a city, for example, there's less real estate to put large solar arrays or wind turbines, obviously, but there are small rooftop solar systems that could be implemented with energy storage, flexible loads, control systems, and obviously those facilities are grid connected as well. Remote mining operations or remote communities. Being in Canada, there's almost 300 communities across the north that rely on diesel power for their electricity. So there's no utility grid up there, and they have anywhere from 2 to 5 to 8 diesel gen sets depending on the operation. It could be any number depending on the size. And those gen sets may be the only form of power generation, but working with the control system at site, that would be considered a microgrid. So a microgrid really can be any shape and size, ranging from residential home to a large industrial facility.
Got it. And so generally, have you seen that it's better to have one that's, obviously in certain circumstances, it needs to be that way where it's entirely separate from the grid. But it sounds like there could be it's pretty good to have it coupled with the grid because it's really just creating a better resiliency. And then could you maybe talk about the benefits of if it is connected to the grid? Like what if you have a microgrid for your house? What are the savings for that? Is there any benefit financially? And then what if you did, what if a larger, maybe a small city also had their own microgrid? What are kind of the benefits there?
Yeah, sure. So at a residential scale, if you have a microgrid at your house, and this came up recently with the Arctic temperatures that hit Texas and really brought the temperatures down to a point where it was affecting local natural gas plants and also the coal-fired peaker plants and freezing water lines, freezing natural gas lines, and the electricity and natural gas supply that the residents relied on to get to their homes was failing, and they were without heat and electricity. So from what does a microgrid do to protect against that is that it provides you that resiliency by having some energy storage or capacity to generate solar electricity at your house, and not rely on the greater grid. Whenever the greater grid is connected to your home, there's financial savings that are available, of course, because your solar PV or whatever distributed energy resources you have at your home are offsetting the electricity or natural gas that you would be otherwise purchasing from the grid. So there's a lot of solar installers and renewable energy installers will provide you with what the ROI is expected for your house if they were to install an energy storage and solar array. So there's definitely some financial savings. There's definitely resiliency play. And of course, there's the sustainability play as well.
Yeah. So one thing I'm curious to understand too, that's just kind of, especially being in New York City, what are the kind of the major components if you were looking at just a commercial unit? Let's say there's a building that they just want to have their own microgrid to power the building. What would the main components be to make that building entirely sustainable on its own from the grid, as well as maybe some of the other things that you guys do with kind of making these buildings, even if they're not their own microgrid, making them more sustainable in general? Because I know that there's obviously a pretty large portion of the population in the world lives in urban areas. So I'm curious to know what are the components there?
Yeah, for sure. So I like to revert to something I saw from Rocky Mountain Institute recently, and it's the concept of grid integrated buildings, or grid interactive buildings. And the idea there is that a building needs to be firstly energy efficient, because that's the number one way to be more sustainable is just to use your energy more efficiently and reduce your consumption of energy. Secondly is distributed energy generation. So from a resiliency perspective, not relying on external sources of energy. And then energy storage, which can provide you savings and resiliency by offsetting peak demands at your facility. And smart controls. So smart controls could be intelligent load shedding systems, connecting your energy management system with your building automation system, and being able to do load shifting to flatten out your load profile of your building. So it's all about shifting loads within your building to times that aren't peak events on the greater grid, having energy storage and distributed energy generation to reduce the demand or need for external energy sources, and being more energy efficient. So the individual components at a building level, it can be from a power source perspective. We see combined heat and power systems. We see energy storage systems, lithium-ion batteries, for example, rooftop solar. From a intelligent load perspective or managed load perspective, which is an integral part of microgrid as well, is being able to control your loads to do that load shifting. So perhaps it's EV chargers, perhaps it's your building automation system, perhaps it's having the ability to shed non-essential loads during times of coincident peaks on your grid. There's huge trends in electrification of transportation. We see that many cities around the world have green building standards where any new construction building needs to be provisioning for 100% electric vehicle charging stations in the building. Maybe not having the chargers there today, but provisioning for it because we see it coming. And whenever buildings have to manage that additional load, there needs to be that intelligent control system. There's going to be a need for energy storage to be able to supply that load to the electric vehicles when needed, and likely a need for distributed energy generation on site as well.
Got it. Yeah. So that actually reminds me of, I think I heard recently that New York had even asked or created some type of law that would require existing buildings to take measures to make them more sustainable. So, I understand that that's generally a pretty expensive process. What are you guys doing? What are some of the things that company owners can do to try to renovate their existing things? Like, what are the components that they will do to retrofit them, right? Because obviously building new is very different. You can be more focused on what you need, all the smart technology, the Internet of Things to manage it. But what do they do when they have to renovate?
Yeah, for sure. So from an energy efficiency perspective, there's a lot of companies that are offering, deep energy efficiency retrofits. So a lot of times it'll start with an energy efficiency audit of some sort. For buildings that are looking to integrate renewables or integrate a microgrid into an existing facility, a lot of times it also does start with that feasibility study. And if the existing electrical system, can be modified or modernized in a way to implement, a microgrid controller, communications to some of the breakers that controlling some of the downstream loads. So there's a lot of retrofit options for integrating microgrid controls into existing buildings. And then it all comes down to, what distributed energy resources or sources of storage can you implement in your building. So a lot of times that, it starts with a feasibility of some sort, whether it's on a distributed energy and microgrid feasibility study. But likely the first step for a building would be to do the energy efficiency audit to make sure that they're using their energy in a efficient manner today.
Yeah. So one thing I'm also curious about is what would you say are some of the trends for new construction, right? Obviously, if they're looking to to be more sustainable in general, is there a difference in kind of how they're building the buildings from an architecture standpoint, just at large, to make it more sustainably, better insulation or something like that, that would help to create this more sustainable type of commercial building?
Yeah. So, well, first off, architecture and civil construction is definitely not my strong point, being a mechanical, electrical background. But what I am seeing is that there's obviously the LEED standards for energy efficient buildings. Here in Canada, we have Canadian Green Building Code or Green Building Standard, where they're actually developing net zero standards for buildings. So that's, every new construction building will need to be net zero carbon emissions. So that's definitely a trend that we're seeing, and that's what's going to drive the sustainability of new construction and even existing buildings, is policy from a codes and standards perspective, as well as the municipalities and the local governments implementing bylaws and energy plans, and also government incentives to incentivize some of these retrofits as well.
Yeah, that makes sense. That's obviously a huge topic, is how much does government involvement help with that progression? I know that a lot of people in general are opposed to regulations for the regulations, but I think that in this case, like it's necessary, right? It's necessary for us to move the needle forward, because sometimes, unfortunately, entrepreneurs or business owners are just going to fall behind. Um, One thing I'm curious, are all the technologies already developed in place to consistently and on at scale to build these new sustainable buildings, kind of these buildings of the future? Are all the technologies there, or is there still areas that need to be developed, or maybe areas that significantly need to be improved?
I think that there's a number of technologies that exist today that will allow buildings to be built net zero and grid interactive, grid integrated, right? And there's definitely, the technologies are being also developed, and algorithms that are going into energy management systems are being developed. So a lot of it is software development as well, that's going into energy management systems. So for example, as a lot of the energy markets are being in like the deregulated energy markets, where there's coincident peak programs, demand response programs, and stuff like that. There's companies that are developing algorithms, technologies, APIs to be able to allow buildings to react to forecasted coincident peaks. So it's one thing, for a company to develop an API with algorithms that are predicting when buildings are going to face a peak situation and face high demand charges. And it's another thing for that building to have the load flexibility and control system in place to actually be able to mitigate those charges. So that's more on a cost perspective, but it is all kind of tied into the whole microgrid concept.
So one thing I don't know if you can speak to this or not, is I'm curious if all of these, there's obviously probably many companies developing these softwares to track and forecast load demand. How can they be integrated with the utilities, right? Because I'm assuming that there's got to be some type of compatibility there, and unless it's adopted across the entire utility, how can that be managed? Are you aware of how that works?
The utilities definitely need to have an involvement with this, and obviously it's the utilities and the regulators that are implementing these, coincident peak programs and whatnot. But what a lot of the software and API providers are doing is, looking at the day ahead pricing. They're getting the information from the utility, so obviously the utility is making that information available. And on the other side, it's the interconnection requirements that customers have to work with the utilities on for net metering and for interconnecting distributed generation as well. So there's different roles that utilities are playing on that front. I'm definitely not a utilities expert by any means, but
Yeah, that makes sense. Well, one thing I'm also kind of just wondering is, in general, what do you see and what have you noticed are the biggest challenges to drive this innovation forward and to continue to get businesses to adopt this?
one of the primary, I'll say, hesitation or roadblock is the energy cost. So if I look at the landscape in Canada and the customers that are adopting microgrids, and it really comes down to cost. Is by adopting energy storage and renewable energy, is it going to actually save them money? And we're getting to a point now where it is. So with things like carbon taxes, well, I can speak to Canada as I'm more familiar with it, but some of the trends that we're seeing. So the carbon taxes in Canada are raising from, I believe, $30 to $170 a ton over the next 10 years. So things like that are going to be coming into effect, where the ROI for distributed generation and microgrids is going to be able to pay off much more quickly. And as well in, let's say, Alberta and Ontario, where they have coincident peak programs and customers can participate in real-time energy markets. There's a lot of opportunities for customers to realize savings from investments that they make into microgrids by making their facilities, interactive with the grids. So, and of course, in areas in Canada where the communities are relying on diesel generation for electricity, there's going to be carbon tax penalties, as well as the high cost of transporting diesel fuel to those communities and to those remote mining operations. A lot of the times now we're seeing that renewable energy and storage, combined with the fact that diesel is really expensive to transport and limited because of the ice roads and the ice in ports in the north as well, that the economics are definitely starting to work out a lot more favorable for end users.
Yeah, and I think that, I mean, I guess maybe you could speak to this too. Do you have kind of an understanding of how the the traditional kind of real estate development mindset is? Because based off of what I've seen, and especially in the U.S. and Canada, I think Canada's been a leader on this. It seems like the social kind of construct of what people are expecting of companies and corporations is changing, and I can assume that a building developer, a real estate developer that can say that their building is completely renewables, you know, totally smart, interacting with the grid, et cetera, could attract more customers probably in the future, right? Because the next wave of business owners, these people, we all care about this. We all care about climate change. So, what are your thoughts on that in general, and like what you've seen as a landscape?
Yeah, definitely. So yeah, historically, I think developers are looking for ways to develop a building at the most cost efficient way that they can, because consumers want to pay the lowest price that they can. But as you said, as the consumer, as the renters, as the occupants of these buildings are changing and being more conscious of the sustainability requirements that buildings need to meet to, get to net zero, I think that, it's not even that they're willing to necessarily pay a premium. It's just that they're expecting it of the buildings that they're moving into. And, you're seeing that across all industries as well, even in the mining industry, where it's being driven through the supply chain, right? Where manufacturers of technology products or batteries or cars are expecting their suppliers and the mining companies that are providing them with raw materials to be, extracting those materials and providing those materials in a sustainable manner. So, that really comes down to companies being more focused on their scope 1, 2, and 3 emissions. So.
Mm. Yeah, what are some examples in that you can point to that people could maybe, if they're interested to know how it's going. Some examples of successful microgrids that are being developed or that have already been operating. Is there anything that you can point to?
I love MicroGrid Knowledge. It's a website and newsletter that I subscribe to stay up to date with any new microgrid news and customer success stories that are happening across North America and the world, really.
Got it. Are there any specific projects that you are aware of that you think are particularly a good example of a successfully developed microgrid that's maybe powering an entire town?
I know that we've done a couple of cool projects down in Montgomery County in Maryland. Those are showcased on YouTube and online, where we actually went in with some other technology partners and finance partners and offered the county what we call energy as a service. So the county paid no money up front, but they get to realize all the benefits of the microgrid and the distributed energy assets at a couple of their key facilities. I believe it was a public safety headquarters and another facility in the county there as well. So that was a pretty cool one, where it was, it's not only is it a microgrid, it was a microgrid that was deployed through what we call energy as a service.
Got it. That sounds pretty cool. I guess maybe kind of just to wrap things up here, what could you maybe speak to the, I know we mentioned it prior to the podcast, kind of speak to the, how important is this in the grand scheme of trying to reverse climate change, right? What is being caused by the current situation, and how much can this be affected in a positive manner through these developments?
I think the potential and need to decarbonize buildings is huge. Between 30 and 40% of carbon emissions in the United States come from the building space. So whether that's buildings using fossil fuels for heating, whether it's buildings, getting their electricity from fossil fuel fired plants, there's 40% of the CO2 emissions that are going to need to be negated in the next 29 years are coming from buildings. So some of the things that we need to do are electrify these buildings, but also decarbonize the grid. So electrify the heating and ensure that all the buildings are being supplied with clean energy, clean electricity. And I think that's one of the real pathways to decarbonizing buildings.
Yeah, 40% is a big number. That's definitely got to be one of the larger components here. So, but yeah, that's really great. I really appreciate you coming on today. Is there any other final thoughts or things that you wanted to offer as we wrap up?
No, I think we've covered a lot of good points here today, Silas. I really appreciate you bringing me on here.
Yeah, absolutely. Thanks so much for joining, and we'll see you next time.
All right.
Hey guys, thanks so much for listening to today's episode with Ryan. Hope you enjoyed the conversation as much as I did. If you had any specific takeaways, please do comment or reach out on Twitter. I'm glad to hear your feedback. Any specific topics you'd like to hear in the future, maybe specific guests you'd like to see. So please do reach out. And if you're interested to be involved further, please do join the Slack channel, even if you're just looking to learn, right? If you have something to contribute, that's great. But we want people who are interested in this space to be able to connect with each other globally to help foster this innovation. And I also want to take a second to break and mention our sponsors. NextWave Partners is who makes this possible. So if you have any specific energy or tech recruitment needs globally, NextWave Partners is the one for you, especially when it comes to more difficult types of searches, things that are not just easily found in the market, which is a lot of the people listening to this podcast, right? A lot of these firms are doing new things, are going to have to find skill sets that aren't exactly available, right? They're going to be people who are in that leading edge. So please do reach out to NextWave. You can learn more and reach out through the website at next-wavepartners.com. And again, thanks to NextWave for sponsoring this episode and making it possible. So as always, guys, thanks so much for listening. Really appreciate the support, and we look forward to seeing you next time.